Hello, hello.
All right, everyone, I'm going to share my screen. And I wanted to start by introducing myself. I'm Bill Kite. I work with Remy at Repowering Schools. Remy's traveling today. I think everybody on the call knew that ahead of time, but she wanted to be here, of course. And she had me set this up today for our guest speaker, Joe, which we're very excited to have. I'm going to have everyone introduce themselves in one moment. I'm just going to start off with just a couple announcements here on behalf of Remy. And to let you know, we are recording. So to let you know that that is happening, and that will go up on our YouTube channel at a later date once we kind of work out any audio and video sides of that. So thank you again for being here today. Just wanted to mention some upcoming events. Repowering Schools is going to all four that you see listed here. We do offer conference experiences, student symposium events, where we do a curated event, and we also pay for the lodging for any participants that sign up. It's a scholarship-based sign up. Travel is on the individual to get there, but we are full for the top two there. But we have IPF 26 coming up in February 9th to the 12th, and AWEA and Arlington on February 23rd and 24th. So we have information on our website that we'll share at a later date once those announcements get out, and we have a link that everybody can sign up to. So keep that in mind. Repoweringschools.org is where we find that out. And then again, to mention that our webinar recordings are on our YouTube page each time that we have our guest speakers, and we also have other events networking through the faculty, and sometimes some competitive events that we put up there in addition to other projects we're doing. So please share and please subscribe. That would help us out. And that's what the page looks like. Remy likes to show that, and it's great that we can have all this opportunity and educational based videos up there for people. And without any further ado, I'm going to introduce Joe. Is it Spossey?
Spossey.
Spossey.
Yes. Apologies. That's all right. Close enough. I've heard much worse.
Thank you for clarifying. Founder and CEO of REInnovations, and I'm going to let him introduce himself. And I appreciate you being here.
Sure. Yeah, I'll talk a little bit about myself in the slides, but I'm the self-made CEO of REInnovations, Renewable Energy Innovations, and we are a testing and advisory services partner for wind turbine manufacturers and wind turbine component manufacturers. Been doing this for almost 20 years now, and I can print while we're getting to hear a little about the others. I can pull up my slides, then I'll talk a little bit more about myself. So you guys go right ahead.
My name's Jake. I'm a senior engineering student at James Madison right now, just pursuing a focus in renewable energy and sustainability, and just kind of pulling at every thread right now, see what's going to land after graduation.
Understood.
Thanks for being here, Jacob. And Nick.
Hi, yeah, my name is Nick Harden. I'm also a senior engineering student at JMU. Pretty much doing the exact same thing, doing some renewable energy, sustainable development, everything and anything in that vein of thought, and just trying to set myself up for the future. And that's pretty much it.
All right. So without further ado, Bill, I suppose I'm good to go here.
Okay.
All right. Well, thanks for being here, guys. And I know it's being recorded, so hopefully some others will have a look and poke around at some of the info I got here. Thanks for having me. I'm going to move it's always, of course, our faces are always right where I don't want them to be. So I got to move us around a little bit so I can see what I'm looking at. There I am with about 22 more inches of hair and a lot less gray and a lot blurrier vision. That was probably 4 years ago. Maybe I need to update my photo there. But a little bit about me. I'm a mechanical engineer, graduated from RIT in 2008. I started off at RIT in an automotive engineering program. And then in 2004, the auto industry was bailed out by the US government, and I switched to a new program where through a mentor of mine at RIT, we actually built and piloted what would be a new renewable energy minor concentration in both the mechanical engineering and mechanical engineering technology programs. I started off building vertical axis wind turbines in 2005, and have basically not looked back. And I told myself I wanted a career in wind energy, and still going strong. In 2009, I started with a company called Intertek. Intertek is a testing and certification company. I knew nothing about certification when joining Intertek. It's not something you really learn about at school. Standards, international standards, and regulatory compliance. But I learned a lot there over my 10 years. So like I said, working on about 20 years of wind turbine related experience now. These days, I focus on really high level things, accreditation of facilities, international standardization, design requirements, test requirements for wind turbines and wind turbine components, and then actually testing the products. That's where I have the most fun. At the end of the day, I'm a test engineer. I love to do things with my hands and collect data and analyze and produce reports. But we offer a wide range of services to our customers. I'll talk about that a little bit. I've been participating in standards development since 2009, and there's a lot of alphabet jumble, and you'll see a lot of three-letter acronyms and numbers and things in here. Don't IEC, MT2, don't worry about it. All that means is we participate in standards development internationally. We've been doing it for a long time, and we lead a lot of the current standards development efforts internationally as well as here in the US. We're considered experts for setting up customer test sites and third-party testing of wind turbines in the field, which will show a little bit about some of that as we move on. A little bit about my time at Intertek and kind of gaining of experience. In my time there, I took I guess nowadays a lot of people will, move from job to job to try to, advance their careers. I was lucky enough to be able to be hired into a company that was growing while I was also looking to grow my career. And instead of, moving from job to job or company to company, I was able to advance my career within that organization. Starting off as an entry-level mechanical engineer, intended to help them build their wind turbine program. And by the end of my time there, I was running the entire program as technical manager for our global wind teams, managing teams in US and London and in Shanghai, having 40 engineers that reported to me through our testing and certification team. In 2019, I separated from Intertek and started Renewable Energy Innovations. But my most favorite project there was the Intertek wind turbine test site, which is pictured there, where we're testing a small 3 kilowatt shrouded turbine, where we set up a measurement tower and then test it to various product standards and produce different third-party reports. And my time there, I did a lot of fun things and a lot of boring things, but you got to do both. The accreditations and sitting through audits with external bodies that come in and evaluate your expertise, and you got to go through those efforts in order to be able to establish who we are in the industry. And who we are now is Renewable Energy Innovations. We are a testing and certification partner. We're not an accredited test or certification body, and that's largely because we help others gain their accreditations. We're an expert who provides auditing and independent advisory services related to testing and accreditation. Formed in April 2019, we really started operations in July. So it's been about 6 years now where we've been going full steam ahead. We have a small team that we work with, on just about every project. Myself, Drew, and Ali work out of Europe for Drew's company, Northwind Engineering. And Matthew, my buddy Mo, who's been a friend of mine for years and was laid off from GE several years back as a data analyst, and that's right up my alley. That's what we do, a lot of data analysis and reporting. So brought him onto the team. But we've got a wide range of services. We've got a wide range of experts internationally that we work with. We basically set up everybody as independent contractors to, when a customer needs a certain thing, we call on that expert to be able to complete that task, design, modeling, or what it may be. But we help both the turbine manufacturer and individual component manufacturers like the generator, the inverter, realize their product through the entire product development process, from a back of a napkin sort of idea to preliminary calculations and understanding then, what the certification requirements are, or different markets around the world have different requirements, different standards. So just helping them to understand, how do we design it? How do we test it to make it safe, right? A lot of this relates to safety. And it's safety of the users. If you're going to put a wind turbine in your backyard or at a commercial facility, right, we want to make sure it meets the grid requirements, it meets the component requirements, and it's not going to fail. And if it does fail, it's going to fail safely. Nobody's going to lose their life. You might have to replace a part or something, right? But there's safe methods for failure. It's not catastrophic. Sure, you see a lot of catastrophic failures out there, right? We can't prevent everything, or can't always model or design for every situation, but we try our best. The only thing we don't really do is we don't manufacture, right? We're not actually building products. We help others build their products and take their product to different markets. We've got a large customer base. We've run about 10, finally, I've said about 6 years now, so we get about 10 new projects every year. Over time, it's transitioned more to testing projects, which is our bread and butter. But you'll see really only, less than 40 customers, which, we've had a lot of repeats, right? So we work, like I said, we work with them throughout different phases. So maybe we help them understand what the gaps are and how to get from A to B, and identify all the things they have to do. And then they'll come back a couple years later and say, all right, Joe, we're ready to do this step or do the testing. And so we aim to provide, high quality service, but we help each OEM differently. We fill whatever gaps they have. Some people or some companies may have a team of 50 engineers. Some may be just a group of 1 or 2 guys, that don't have capabilities for certain things, and that's where we come in. We participate a lot in Department of Energy and other grant programs. Since 2019, we've participated in almost 18 different federally funded projects that were awarded through a competitive program, which I think is the most of any non-OEM for sure. And then we also have our own direct subcontract with NREL, which I'll talk a little bit about on one of the next slides. But we see all sorts of different types of turbines: vertical turbines, horizontal, upwind, downwind, active controls, passive controls, big, small, right? Everything in between. We've got up on our website, you can find out more about the type of customers that we work with. Website's just REInnovationsLLC.com. And, we've got a lot of satisfied customers, some feedback there from certain customers, but some of those, I think Mike Berge, Berge Wind Power is up there. We've been working with Mike for more than a decade, dating back to my time at Intertek, and same with Northern Power. That might be a familiar name and a familiar turbine that we've been working with. As I transitioned out of Intertek and into this new role and experience, a lot of the customer base followed, right? And we provide, like I said, a wide range of services. Where I'm going to highlight a couple of these, talk about some of these projects. Code Air Wind specifically, I think, on the next slide. This is our customer out of Ireland, where in late 2023, we helped them basically turn this, what was just a field, right, into a wind turbine test site. So this is mostly what I enjoy doing. I am an engineer, and every once in a while I have to play CEO, but I enjoy helping set up test sites, and we do this all over the world. And this was in Ireland for these 2 turbines, a 20 and a 30 kilowatt. And, full site assessment. We're going from, a topographical survey map, looking at the terrain characteristics. Is it complex terrain? Is it flat terrain? To understand wind flow, right? That affects how the wind flows around the turbines, as well as objects, buildings, tree lines, other obstacles that could potentially be there or provide turbulent airflow. We do what's called a site assessment, obstacle assessment, and basically say there's objects in this area. We're going to accept wind out of this small little sector, and then we produce our test reports. Right? For this customer, we also had Drew performing full design assessment. So these turbines were designed and tested by REInnovations, full aeroelastic analysis. That's a simulation model tool that's out there for wind turbines specifically. that basically takes all the wind forces and translate to rotor forces and moments and translates to shaft forces and moments, and then on down the tower and into the foundation, right? So these turbines, we help them full structural analysis, and then moved into testing, right? So these two turbines went through a full certification program and have recently been awarded certification. So they've completed program. You'll see, a power curve there, right? That's produced by REI, right? The point of the certification is not to have OEMs telling you their power curve, right? It's an independent analysis. It's an independent report that says, here's when it's connected to a grid, including all system losses. Here's what the actual power is, that you can expect. There's a range of tests that we perform: power, duration, which is just like it sounds. It sits up there and spins. It's got to go through its range of motions and RPM, right? And safety and function. Safety and function is a fun test. That's where we push all the emergency stop buttons and we see the turbine go from full rotational speed to 0 in 10 seconds. And we observe, right, what happened. Did we hear cracking? Did we see damages? Right? It has to go through basically any control or any protection method that the turbine system employs. We got to test it. We got to make sure that it works, right? So that's an independent test that we run. And then acoustic noise. I don't want to call it an issue. It's a topic that everybody talks about: wind turbines, acoustic noise. So independently, again, we produce tables and plots that say, if you're a person standing at this distance, what kind of noise can you expect this turbine to make? And, in my experience, right, usually turbines aren't the loudest thing in these fields. When we tested these turbines, the factory, the cows, right, you hear those over the turbines. And as the wind increases, the sound of the wind is louder than the turbines themselves, right? So these reports help explain those things to planning boards and permitting officials, right, when you're trying to permit a wind turbine installation. Another one, Northern Power, I mentioned, we also went through full test site development. They're testing their latest C platform 100 kilowatt turbine in Italy. So we helped them develop their test site there. And we also help them with electrical safety advisory services. So that, as I mentioned, we're not a certification body. So what we do is we know the standards, we understand the products, and most of the time, the OEMs themselves don't understand the standards as well. So we help interpret the requirements for their product. If you have an inverter, if you have these components, what do you have? What other standards must you comply with? Or, what type of wiring connections and things have to be made in order to be safe, right? Those are all contained in product standards. And so we perform design assessments to help them figure out their gaps and how to bring a product into compliance. So there's our latest power performance results for Northern Power, and we're running through some other tests for them for a larger turbine of their size. We also have to do a loads validation test, strain gauges on the tower to measure base bending in the fore-aft direction, for side to side bending at the base of the tower. So there's a couple, as the turbines grow, some of the requirements get a little bit more difficult as well. And then just a little summary of some of the other projects. These were all DoD or NREL, that says CIP, which stands for Competitiveness Improvement Program, which is a DOE funded program that I was referring to earlier. Lots of different turbines, right? 90 kilowatt downwind stall regulated horizontal axis turbine, the 100 kilowatt Northern Power upwind 3-bladed horizontal axis. We've seen every type of vertical axis turbine you can ever imagine, and tested many of them. The DoD project there was for rapid deployable defense systems, being able to quickly deploy a unit for charging batteries or, helping soldiers in the field. And then we've got a couple, actually, there's one or two missing there, but right, we've got several other projects where we're running through full test programs, and then a few where we just help, right? We help the OEM. They just don't understand, or they need us to be the person who is the liaison with the certification body. We pass documents back and forth. We interpret what the CB needs or what they require, and then we tell the OEM how to react. One of the projects I worked on personally directly with NREL and with Department of Energy was the publishing of a certification guideline. And, this is it's not an easy read. It's a 100-page technical report, if you will, that from A to Z covers wind turbine certification in North America, in the US specifically, but in North America, the requirements aren't all that different. So this covers everything high level on just product certification and, hair dryers. I don't talk about hair dryers, but it's all the same. If you're a fan or a hair dryer, you got to go through North American third-party certification. If you're a wind turbine, you've got to go through North American third-party certification. Obviously, the standards are different, right? But they all have design requirements and test requirements that they have to go through. And this document attempts to explain all that in one place. Usually you're kind of taking pieces, parts, and going to find this standard and this standard and this standard, and we've just kind of put it all together and organized kind of in yes/no checklist fashion, what applies to certain products, and that helps manufacturers prepare for certification in the long run, just understanding what the requirements are. Some other quick project examples in that field there that is shown there is actually the National Wind Technology Center at NREL, where I went through some of my training, and some of these turbines were placed in the previous slide. But just to that's a real test site. That's a DOE test site there. You see 2 megawatt turbines and some other 100 kilowatt turbines, and there's even smaller turbines right that are tested there at their Golden National Wind Technology Flatirons campus. That's where I went through all my training, right? When I was a young engineer as well, I physically went there to do and learn how to do these tests. But just some other examples of other turbine types, and all around the world, we find international customers out of Europe and Australia and Asia. When they need to bring their products to the US, as I mentioned earlier, the requirements aren't always the same. So they engage with us to say, hey, we've got this, and what does that need to be in order to be compliant in the US market? A little bit about some of the volunteering work that I do. Not a lot that you need to really pay attention to here, but standards development is volunteering, right? And in some cases, I pay to play in some of these groups where we have to pay membership fees in order to be able to be involved in these committees. But I've been doing this for so long that it's second nature, and really all you need to know is in this process, we're constantly trying to make the standards better. That doesn't necessarily mean more difficult. It may be easier for the OEM to get certification, or cheaper, right? We're always trying to improve the standards for both the user, right? Who's going to use the product, but also the OEMs that have to design to these requirements. The 61400-2 document there hasn't been updated in 12 years, right? So there's a lot of old technology, old requirements in there, and so we're going through the process of updating. We've added some different classification turbine sizes to help segregate what the requirements are. And we've, I've been doing this now for a while, but we've, what used to be the American Wind Energy Association, now American Clean Power, I think I've been participating in the longest, and helped them write 6 or 7 different standards over the past 10 years, and same under IEC as well, which is the International Electrotechnical Commission, which the 61400 series is really the international norm for wind turbine standards. So in the US, we've got ACP 101, but that's based off of all the IECs. So that's really where the bulk of all the design and test requirements are. You're going to find in those IEC 61400 documents. And as students, I don't know, maybe you guys might have access to some of those through some of the databases and resources that you guys have access to. Couple more slides really quickly here. What's next for us? Changes in the industry. This is always one of those industries that ebbs and flows with politics, and that's fine. So we tend to shift our focus periodically, and one of the main issues right now is the inverter, the actual piece of equipment that connects the turbine to the grid. Most often the manufacturers of the turbines don't make the inverter themselves, so they get that from somebody else, and usually it's made for PV and not for wind turbines, right? So there's some nuances there, AC, DC voltages and things that have to be considered and maybe retested. But also moving more towards like hybrid systems and microgrids, where you see wind turbines and solar panels and battery energy storage, and how do all those things play together in one installation, either connected to the grid or as a microgrid. We're working on revising that certification guideline, right? As the standards update, we need to continue to update our document that's available on our website. We're also working on some accreditations. That's kind of a long-term thing, just as a formality. We've got all the paperwork for it. It is a large expense for a small operation, but it does help with some of the international efforts and some of the international customers it helps more with. And then recently here, recent news in just over the last couple of months, we've started to cooperate a new test site in Texas where we're testing small and medium wind turbines, and in 2026 looking to expand that a little bit more and talk a little bit about that and growth and hiring. Here's that site. It's it's in the middle of nowhere in the panhandle of Texas. It's this little field which is actually 20 acres. That little green box is a 20-acre box. And there's a slightly larger rectangle that's about 120 acres that we're looking to expand into for testing larger turbines. There's 2 turbines there right now. We've got 2 more coming later this year, and always needing help at sites like this. And that lends a little bit to some of the discussion about potential opportunities with REinnovations. And we're very flexible. That's the way we've built our business. And even if we have some contractors who work with us just on 1 or 2 projects for a week or 2 at a time, and some who work with us on every single project, like Mo and Drew, who have certain tasks that are basically always there on every project. But even just installing measurement towers as we get older, David and myself at the test site in Pampa, it's a little harder to install these towers ourselves, and we're always looking for hands. And we do this all over the world, and we don't always have help all over the world. So certainly into the next year, into 2026, we're scaling up at our test site in Texas, and we'll definitely be looking for more of the hands-on type who are willing to install some towers, do some basic data systems, data collection, anemometers, wind vanes, data logging, connecting to computers. We don't usually touch their products, right? We don't want to screw anything up with their products, but we need to know how to have a system collecting data ready to go when they arrive, right? So we've got our measurement tower up, and we're collecting data from the moment they set up on site. You don't have to be an engineer. Data analysis, statistics, or in physics, or even math majors. We do a lot of data analysis. I was not a fan of statistics in school, and I didn't realize that I'd be doing nothing but statistics in this job. So I've been doing statistics now for the last 15 years. So that's one of those, I don't even think I scored well, honestly, in statistics, but now I'm an expert, right? And you gain that knowledge a little more as you work in the field. So we'd be happy to, if this sort of thing is something that people are interested in. We've always got opportunities, even those short-term ones, to help us install a tower, take a tower down, and even testing systems as you get more experienced with that. I work from home. I work remotely. I test all these turbines all around the world from my office at home, right? So there's data analysis and reporting can all be done remotely. So we're very flexible, and looking forward to possibly bringing on some help in the next year. That's really all I had for you guys today, but I'm certainly able to talk more and happy to answer any questions.
Thank you, Joe.
Yeah.
I'll leave it to start with Jacob and Nick if they have any questions.
Yeah, so I'm just getting into the renewable energy game, really. So I'm learning more every day, but I'm familiar with the Distributed Wind Energy Association, and Mike Berge did one of these calls earlier in the summer. And the Small Wind Certification Council.
Yep.
So I'm familiar with that, and I guess that was like the only certification that I'm familiar with before this call. So like, what other ones are there? Or is that like the main one that you're doing?
Yeah, that's the one when I go into the Code Air, right? That's what they fed into. These reports fed into a Small Wind Certification Council certification, right? So we're an approved test laboratory by the SWCC, right? So SWCC comes on site, does an inspection after we're all set up, and then we run all our tests, produce all our reports, and the OEM submits a package of documents, and they get certified, right? But in the US, that's really for distributed wind turbines. That's really, I'll say that's it. There are others, but I wouldn't necessarily suggest them. Small Wind Certification Council was built intentionally for this, in partnership with NREL and DOE. So I would, if you're, if small turbine going through certification or design, you go to SWCC. Internationally, there's a much bigger picture of wind turbine certification. There's a whole scheme. It's called IECRE. And in there, there's you can Google it. It's IECRE.org, I believe, is just the website. And they'll have lists of test laboratories and certification bodies, but there's certification bodies all around the world that can do these services, similar to SWCC, but that's just most commonly what we use in the US. And then lastly, there's electrical. I mentioned electrical safety. That's a completely separate beast. Everything we just talked about SWCC is field testing of a complete wind turbine system, right? With the power, acoustics, duration, safety and function, and loads validation. Electrical safety is laboratory testing of individual components, the permanent magnet generator, the inverter, the converter, resistive loads, diversion loads, slip rings. Any component that's used in the overall electrical assembly has its own UL product standard. And UL is Underwriters Laboratory, and they're the SDO, Standards Development Organization, that is primarily used in the US for electrical safety standards. And they've been around forever. They have, standards and committees dating back into the early 1900s. I believe UL was formed in 1950, but the standards and the programs and the standards that they now maintain have been around for decades. So UL is probably the most common other certification in the US. Intertek, the company I worked for, was ETL, right? Everybody's got a certification label when you look at any product. Hair dryer, a fan, your computer, it's got a label on it. And that label's got a FCC marking and a UR and it's got all those different labels. All of those labels actually mean something, right? They all mean that somebody else has looked at some aspect of that product, verified it complies with a product standard, and then put their mark on it. They say, we have evaluated this product to say that it complies. So there's a wide range of, certification offerings and services around the world for wind turbines and other products. Product certification is a very broad category. But that, if you're interested, that's one thing that we do talk a little bit about in that certification guideline that you can download from our website. The early sections in there just kind of talk about certification in general, and then talk more about how that applies to wind turbines.
Great, thank you.
Yeah. Any others? I know also we can talk a little bit about some of the SonSite specific stuff if you want to, but also Nick, certainly if you have any questions, or Jake, any other questions, please.
Wow.
Great.
I do. I have a lot of questions. I feel
Right.
like I don't have a lot of time, unfortunately. We have another meeting lined up. But one thing I did want to say first was the opportunity to come install some of these wind towers, whether it's the measuring equipment itself or the tower itself. I know I personally would be very much interested in. I know you mentioned the site in Texas, and there's also the one in Beach Mountain that I think Jake and I are
Beach
both
Mountain.
aware of.
Yep.
That I think we're both interested in participating in if that's an opportunity.
Absolutely.
Yeah, and I think it's really an amazing opportunity, and I guess some of the things that came to mind, I'll try to keep this as concise as possible.
Mhm.
But on a national scale, local scale, or even an international development scale, from what I understand, there's different manufacturers, different turbine systems, and you're not so much going in there and so here's a turbine that we ourselves have designed. We're taking your own just one manufacturer, whether it's something you bought or something that you want to sell to people, and we're offering you, the ability to analyze your system, get it certified, understand it structurally, whether it's when it's being implemented or after it's been built. We want to understand all the different aspects of it. I think that's incredible. I really enjoy something like that. And you mentioned this thing called safe failure, and I really like that term. Because in some of our undergraduate classes, especially in our design courses, we look into stuff like that where you always look at the big failures because they're catastrophic and they can often be awful. But to design something with like, okay, when it does fail, if it fails, does it fail safely? I think
Right.
that's a really important thing to look into. Um, yeah, sorry, these are like questions, but not questions.
It's
I think
okay.
the
No
one
worries.
real question I have
Sure.
is this idea about data analytics and
Mhm.
embedded systems. I don't know if you've looked into like the embedded systems you have for your measurement devices, but could you tell me more about that as like a feature of data analytics as technology increases and we get more and more robust data collection, devices or processes. What sort of embedded systems do you guys have in your wind
Sure.
turbines?
Yeah,
Yeah.
the standards are pretty strict and are evolving. And as you know, the term, standards always lag behind technology, right? Standards don't look forward and try to presume what may be there. They go by what's here now or what have we learned in the past and how do we address that in the current standard. So they haven't gotten, AI tools and, fancy tools for helping with data analytics. Basically, we've had to develop it all ourselves, put codes and
Mm.
simple tools like MATLAB or even just using Excel. I mean, we use Excel all the time. And so it's still fairly simple, but that's because it can be and it helps keep costs down. But I say that for what we do. But if you ask that same question to Peter Gregg from GE Vernova, he's going to say we've got this real fancy tool that we use, and that's just what they use to qualify their product, right? And they may do that in certain places around the world, but they won't be able to use that tool for certification, right? Because they got to use what the certification body has, if you will, right? They bring in their own
Yeah,
equipment
yeah.
and set it up. And that's what we do, right? We've got our own equipment and we get towers from guys like you and we borrow them and we use them. We help because one of the things to remember is we're talking about distributed wind here. And yeah, Mike Berge's been around for 40 years, but a lot of these guys haven't. And they only have one or two people and they don't have a ton of money to spend on sophisticated systems. So they really need it to meet just what the standard requires, and that's it. So there's a balance there where if we have all those super sophisticated systems, then we're gonna, it costs us more to maintain, to learn, to use, then it costs our customers more to use our services. So like I said earlier, we kind of tailor every single project, every single program to an individual customer on what they need and what they're capable of withstanding from a financial and resources perspective, right? So, we've used basic cup anemometers. I'm not using ultrasonic anemometers even, right? We use old
Yeah, yeah.
school NRG wind vanes still because the other ones are more expensive, but they don't really give us more accuracy. And we've sort of settled on certain other, barometric, we measure other, I'm a unofficial meteorologist, right? We measure all sorts of meteorological conditions and take 1 second data, right? I'm looking at months worth of 1 second data and producing averaged, 10 second, 1 minute, 10 minute average data, standard deviation, max min, and trying to understand what the turbine's doing in those periods and kicking odd periods of data out. And then you're left with a good chunk of data and you analyze that and produce a report. And most of the analysis part, and even down to the equipment requirements, is in the standards, right? The
Mhm.
equations to some degree, a lot of it is experience driven, but that's all in these international standards. The IEC standards are 400 pages long, right? And they'll cover an
Yeah.
individual test, one test per document, and it's 400 pages long because it gets into all those details. So unfortunately, the
Wow.
standards and certification aren't really sophisticated yet, but they are working
Mm.
towards that. And I mean, we use any data logger system that meets the requirements of the standard. We've used Campbell loggers, onset loggers, National Instruments, a couple, international ones that I'm not even going to be able to pronounce that are similar to Campbell loggers that we have to evaluate each one independently. We have to look at it, what's it capable of, what kind of signals can it accept, pulse channels or milliamp channels, right? It's all those individual details.
Yeah.
And that's the sort of
Yeah.
stuff
From
that we're
an
doing at beach, right? At the beach mountain site, we've already
mm,
nailed down a lot of those details and we need help connecting all the dots.
yeah, yeah. I imagine from an international, especially from an international development perspective, that's got to be tedious task to try to not
It
only
is.
talk to your stakeholder, people you're working for, but to then be like, okay, these are the expectations. Here's the standards you work with on a day-to-day basis. Like, how can we bridge this gap?
Right. And I
Um,
mean, there's not a lot of people who are experts in this space, honestly. It's kind of a niche market, and
mhm,
um, but I hear that all the time where it's like, we've never even, we don't know anything about these standards, Joe, and thank you so much for helping us with this. Just people just don't have this experience, and it's something that I've, dedicated myself to for almost 20 years now. So, it may not have been the most interesting at times, but it certainly paid off in the end. So, it just takes some hard work.
mhm. Thank you.
Yeah, no worries. Oh, and you were talking about failures, right? Failure modes and effects
Yeah, yeah,
FMEA,
absolutely.
right? If you're in your design class, you might learn about FMEA or risk assessment. There's standards for those, right? And those standards are in that document as well. If you go in there and you search risk or you search FMEA, there's a couple of individual standards that are referenced there. And it talks about how likelihood of a certain type of failure happening, or gives you different probabilities of occurrences that you use, and you basically calculate out the risk into a number. And is that number greater or less than 1, or on a scale of 1 to 10, what is that number? And that gives you your severity, and from there you've either got to put a protection, a brake, or some other protection in place, a limit on a wind speed or a rotational speed to prevent that event from happening, right? But it's that
Mhm,
risk assessment, that failure assessment that gets you there. You got to understand first how it can fail, and then what you can do to protect it. What's the severity of that? What can happen if it fails? What other systems are going to fail? And how do you protect it? So
mhm.
for sure, that's an area of interest, failure and understanding failure modes.
Wow.
Yeah, yeah,
Any
yeah. I mean, yeah, unfortunately, I feel like I might have to go. But if
No
Jake
worries.
has any extra questions, I'll definitely email you if I have some things more
For
to
sure. Yeah.
mention.
My,
Talk
I
about.
think you already have I think you're
Yes,
already on an
yes,
email with me. But it's just first name, last name at
yeah.
REinnovationslc.com. Check out the website,
Hmm,
poke around a little bit, check the report,
hmm,
try to answer some of your questions. But yeah, we'll talk more about Beach Mountain specifically. And that's an opportunity even with App State. If we get some kids that view this recording online, where it might be a good opportunity for you guys and App State to work together to help us. We need to get a tower there, the measurement tower. We need to get that tower up and installed, and probably with the equipment on it and data logging. So it would be
hmm,
a trip to Beach Mountain in a couple days on site, putting the tower, anchors in the ground, and learning how to do all that stuff, and wire together some low voltage. None of it's risky business. It's all easy stuff, but as it gets harder for me to use them little tiny screwdrivers in them boxes and tighten those terminals. So we're always looking for more
hmm.
help.
Absolutely. Yeah. Thank you for the opportunity. We'll
Absolutely. Looking forward to it
definitely be in touch.
for sure.
Yeah, and we'll also send this out as well, through Remy. So it's better to have you directly connected, of course, Joe, with the
For
two on the
sure.
call. But Joe, that was so informative and detailed. Thank you so much.
Yeah, no worries.
I
No worries.
appreciate
Happy to be here. Thanks for having me.
Yeah.
And hopefully get some interest and some people who want to reach out and talk about this more. This is
Yeah.
this is what I do every day. So happy to talk about
it.
it.
Mhm.
Excellent. Jacob and Nick, thank you. If you have to jump off, I totally understand. We do these weekly, so we have two more coming up the following Wednesdays. Just to let you know, if you're able to come back on, we have a representative from Soul System coming up on our next talk. So if you are able to do that, that'd be great. Her name
Yeah.
is Leah.
Think
Torres.
we'll be at the ACES Solar
We get the
Conference next week.
solar
So
conference.
Yeah, so will Remy. That's fantastic. Fantastic news. Great. Well,
It
let
seems like she's right up that conference's alley as well. So
Yes.
that'll
Yes.
be.
And I'll be at DWEA. I'm there every year. I usually sponsor the Distributed Wind Energy Association event in Arlington every year. We sponsor and do a presentation on a detailed topic about certification every year. But that's a good event to just, it's a small group, really. This is a
I
small
think I'll
industry
be able to
group.
go actually.
No worries, Nick. Everybody knows everybody. So it's a good place to go and meet all the players in the industry, really. Everybody's there.
That would be good.
Cool. Well, if nothing else, Jake, if not, you can certainly ask me questions offline. I know you had that other project that you may have wanted to talk about. We can take it easy. We can talk separately about that if you want. In short, we don't normally advise too many on which turbine to use. And I will say, and you were mentioning 600-watt vertical turbines. There's not many of them, right? So I could point you to a 600-watt. Actually, I just say go to the SWCC website because they have a 600-watt turbine that was recently certified. It's a horizontal. So if I'm ever going to suggest a turbine to you, I'm going to say try to find one that's certified, right? Especially if you're going to be using it for a program like DOT. You want something that has a better chance of positive results, and taking a product that's certified into that project would be advisable. From a vertical standpoint, it'll be a little more difficult to find one, but I'd be happy to help poke around a little bit on some options. You can also look up Primus, formerly now Rise. They're out of the UK, but they have a product line. The Skystream is an old turbine. You may have heard that name.
Yeah, we got one in the warehouse.
Slightly bigger than, right, but AirX, the Breeze, those turbines are 1,000 watts and less. Also horizontals, but you might find that you have to pivot between vertical and horizontal to two different types of horizontals and see how they perform. But it sounds like a fun project, and I'd be happy to help answer some more questions there if you do have some down the road.
Awesome. Yeah, it's VDOT just wants everything along the roads is just powered with solar batteries and maybe a diesel generator.
Sure.
So they're looking at, throw a wind turbine on it. Is that gonna cost less maintenance on our end? We don't have to send guys to clear snow, or if we have a whole cloudy week. But then, like, academically, our director here, Dr. Miles, he's just like, hey, this is like a really good testing opportunity too, to collect some data while we've got those out there.
Yes.
So
I actually know Dr. Miles. I've met him a few times. He used to participate in some of the old AWEA committees, so I've met him face to face, and have always been looking forward to working some with JMU. So I'm hoping we get that opportunity now.
I will pass that along.
Absolutely.
Definitely.
All right, Bill.
All right. Well, I wrote down those names, and thanks for the advice.
Yeah, absolutely.
Thank you.
Appreciate it, Joe. Nice meeting you.
Yeah. Thank you, Jacob, for being on the call.
All right.
I guess we can conclude there. So once again, Joe, thank you so much for your time and your wonderful presentation. I'm glad that everyone connected here. That was great.
All right.
All right.
Thanks, everybody.
Thank you. Bye.
Take care.
Take care, guys.